Okay, welcome back. This time we're going to talk about rotational symmetry. Make sure, and really do, make sure you watch the video by Mr. Gilbertson that illustrates how rotational symmetry is done and what this word of order means, because I'm not going to explain it here, so I just want to make sure you know what it is so that we can fill out our notes and do our bell work. So, define rotational symmetry. So, rotational symmetry is when a figure rotated about its center maps onto itself. Now, mapping onto itself means as you turn the object like a doorknob, everything will line up, and for a split second, it'll look like the object you hadn't rotated at all, but you had rotated it, right? That means it mapped onto itself so perfectly you can't tell that anything changed. A figure has an order of 8. Explain what this means. An order of 8 means as the object is rotated, it matches up 8 times. Remember, an order of 1 means it has no symmetry at all. You have to go all the way around. I don't know why it's doing that. Let's go back to our board. Okay. It has no symmetry at all, and you have to go all the way around before it matches up. Okay. So a figure has an order of 7. What is the third degree of rotational symmetry? So remember, an order of 7 means it will match up 7 times, right? I can rotate this thing 7 times and it'll match up, right? So to calculate how far I've gone, 3 degrees means I've rotated 3 times. So I'm basically going from 1 to 4. Okay, I've rotated 1, 2, 3 times. How far have I gone in those 3 times? Okay, and the way we calculate that is a full 360. So each of the 7 rotations is 51.4 degrees. Okay, each of those rotations on the way around is 51.4 degrees. And I'm going to go and do 3 of those. So the third degree rotation is 154.3 degrees. Okay, depending on how you round. Okay. Find the degrees of rotational symmetry for the given figure. The figure does not have rotational symmetry, write none. Okay, so you're going to figure if we maybe start at this corner, as I turn this object, so if it goes all the way around, that's 1. So that's no symmetry right here. As I start to turn, will it have more symmetry? So as I pivot this octagon, it'll match up here, it'll match up here, it'll match up here, 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 and here. If this helps, go get some trace paper off the shelf and draw your figure and twist it and see how many times it matches up. You're going to find out that this has 8. This is an order of 8. Okay, so all the degrees of rotational symmetry. Okay, so this has 8 degrees or an order of 8. Okay, this arrow, double pointing arrow, so remember we're going to pivot right around this point. We're going to spin it, and it looks like this point will end up matching up over here as well. So this is a 1, this is a 2. Remember, 1 means no symmetry, so every object has at least an order of 1. Okay, order of 1 means the starting position, and it'll also match up over here, so we give that an order of 2. Okay, now if we want to do degrees of rotational symmetry, that means that 360 degrees divided by 8. 360 degrees divided by 8. So that means every, oh my goodness, why is my brain not working today? Every 45 degrees, okay, every 45 degrees, so each of these is 45 degrees, it'll match up. For this one, 360 is all the way around, right? We're going to divide it by 2, which is 180. So this is 180 degrees of rotational symmetry. Find the degrees of rotational symmetry for the given figure. This cloud is not perfectly rotationally symmetric. If we take the 1, even if we rotate it over here, there's items down here that do not match the items on the top. And you can prove that with trace paper if you trace the details. So this is an order of 1, which means that's 360 degrees rotational symmetry, or it doesn't have it, right? It's none. The sun object, if we say it starts here, it looks like it's going to match up all the way around, having 8 degrees or 8 order of rotational symmetry, right? It's going to match up 8 times, all right? And we did this before, so 360 degrees divided by 8 means every 45 degrees we have rotational symmetry. Okay, explain how you can tell the figure has rotational symmetry, and it means it lands on top of itself as you rotate it 360 degrees. You are now ready to do your assignment.